Hello everyone, I hope you're having a great day so far. Today we're just going to get into some more notes with exponential functions. If we remember back to our last lesson, we talked about exponential growth. So what I'd like you to do, if you haven't already, make sure you do the bell ringer. If you haven't done it, maybe you want to pause the video. If you've already done it, then just let it keep playing and we can go through it together. So, thinking about our exponential functions. We know our exponential functions always look like this. Y equals A times B to the x powered. A, again, represents that initial value or that value that you start with, and B represents the growth or decay factor. We know from our last lesson that if B is bigger than 1, we're looking at growth, and if B is less than 1, then we're looking at decay. So, thinking about this question, it says an investment of $2,000 triples in value every 5 years. Write a function that represents the value of the investment after 5 years. So, we have to fill in what we know into our equation. So, we're going to say y equals, again, A is initial, so it looks like we're starting with $2,000. It's tripling. So times B, so B would then be 3 to the x powered. But here for x, a lot of us are probably thinking, well, maybe I should put 5 in there. However, it says that it triples every 5 years. So how many times would it triple in 5 years? Just once. So I have to put in a 1 for x. When I go ahead and evaluate that, I'm going to get y is equal to $6,000. So that would be my first part to the bell ringer. The second part then says, how much money would you have after 25 years? So we're using our same formula as the first part. So I still have y equals 2,000 times 3. However, this time for my exponent, since it's for 25 years, and x represents every 5 years, we have 5 5-year spans in 25 years, so our exponent would be 5. Again, you got to use calculators for this. You just have to type it in correctly and slowly. So you should get your answer to be y is equal to, or how much money you have is equal to $486,000 if you let it triple over time, over 25 years. Hopefully that one went okay for you. Right now, though, we are going to go ahead and move ahead and start talking about decay. So we know with exponential growth, our numbers start out small, and then they get real big, real fast. With decay, however, our numbers are going to start big, and they're going to get really small, really fast. So here we're just going to jump in right into our formula. Remember, very few things that we talk about are just going to, especially when we're talking about growth, just double or triple, right? We said a lot of times with money, it's going to increase by some percentage. Same thing with exponential decay. We're going to talk about it in terms of decreasing by some percent. So you should notice that this formula here is very similar to what we talked about when we talked about exponential growth by a percentage. A still represents my final amount after decay. Remember, we can just say that that is y. They just used A instead. P is my principal amount. Remember, when we're talking about money, a lot of times they call it the principal with what you start with. But if we think back to our normal exponential form, y equals A times B to the x, P really just represents A here. T is still my time period. If you want to use X instead of T, I'm fine with that. Or if you want to use T, it does not matter. Again, this is a vocab we have to be aware of. R represents my rate of decay. Or in other words, that's my percent as a decimal. So just to recap, if I tell you that you are decreasing by 3%. If I asked you what the percent was, you'd say 3%. If I ask you what that rate is, you would say 0.03. Right? You always have to move the decimal over 2 places, or think about dividing that percent by 100. Finally, the last word we got to be aware of is decay factor. Really, that's just the B, or this part of my formula, this 1 minus R. That's my factor, or we more commonly refer to it as our B. And again, you just have to take 1 minus your rate when it is decay. Remember, with growth, it was 1 plus my rate for my factor. With decay, it's 1 minus. Otherwise, the formulas are virtually the same. So hopefully that made sense to you. We're just going to jump into some examples after we look at this graph here, just one more time as a refresher. So again, the big thing with decay, my B value has to be less than 1. We also say that it has to be greater than 0. We're not going to deal with any negative numbers. So things that are less than 1 but greater than 0, things like a half or 3/4 or 5/8, those sorts of things. And again, my graph, just looking at it, as I go from left to right, it's getting real small, it's decreasing. And remember, the big thing to point out is that my graph never touches the x-axis, right? I never decay completely to 0. So here is our first example. We'll just read through it and then answer these questions. Remember, I always break them down into kind of smaller pieces for you. So it says, you bought a used truck for $15,000. Says the value of the truck will decrease. Okay, so this tells me it's an exponential decreasing model each year because of depreciation. Whenever you see the word depreciation, that tells you decay. It's losing value. It says the truck depreciates at a rate of 10% a year. Estimate the value of the truck in 5, 10, and 20 years. And just one thing to point out, the reason why they say estimate, it does not mean that in 5 years it's going to be exactly this value. Just based on kind of trends, that's what we can estimate to be. Obviously, if you get a crash or something, right, the car is probably going to be less than what we might get for what it would be worth in 5 years from now. So starting up, it says, what is your initial value? So hopefully this feels like a freebie for us, right? We start at $15,000. It says, what is our rate of decay? Okay, again, our rate is our percent as a decimal. So I have to convert 10% to a decimal. So if I look up here, the decimal place would be here. Got to move it over 2. So it would be 0.10. Or you could just say 0.1. You don't have to put the 0 at the end. They mean the same thing. Next, it asks for my factor. Remember, my factor is just 1 minus my rate. Since this is a or a decay problem, so we do 1 minus 0.1, which is going to give me 0.9 or 0.90, whatever one you choose. Next, it tells me to write my exponential model. I really just like thinking about it in terms of this first one because that's what we're most used to. So I'm going to say y equals A. A is my initial value, which is 15,000, times B. In this case, B is my factor, decay factor, so it's times 0.9 to the x. 0.9 to the x. So there's my model. Now I just have to go ahead and do some evaluating. It says find the value of the truck after 5 years, 10 years, and 20 years. So to find these things out, I'm just plugging these values, the 5, the 10, and 20 in for x, because x represents my time frame, and it says that it's depreciating per year. So I'm going to first plug in 5 for x. So I get y is equal to 15,000 times 0.9 to the 5th. I would maybe take time to pause the video and try plugging it in yourself. That's a big part of this. When you plug it in, the value of your car, since we're talking about money, you got to have a dollar sign. It's going to be $8,857.35. Now we go ahead and do the exact same thing for 10 years. Instead of plugging in a 5 for x, we're going to plug in 10. 15,000 times 0.9 to the 10th. Since this is decay, you should be thinking, well, this number should definitely be smaller, right? As time goes on, our value of our truck should decrease. And in fact, you should get $5,230.18. Finally, just the last one, plugging in 20 for x, equals 15,000 times 0.9 to the 15th power. You should have gotten $1,823.65. $1,823.65. All right, hopefully that problem felt okay for you. We're going to kind of continue on with this problem, just do a little graphing, just to see what that decay is going to look like. So we've already found some of these values already. If we think back, we found what the value is going to be after 5, 10, and 20. So I'm going to fill those values in. For 5, we had $8,857.35. For 10, we had $5,230.18. And for 20, we had $1,823.65. To find 15, you're just going to have to go back and plug 15 in for x in your equation. And I can let you do that. I'm just going to write down the answer right now. So if you want to plug it in, maybe pause the video. But you should get $3,088.37. And then for the first one, for 0, I mean, you could definitely plug in 0. Right? We'd have then 0.9 to the 0, which anything to the 0 power we know is 1, times 15,000 would just be 15,000. Or we should know at time 0, when years is 0, that's just my starting value of my car, my truck, I guess, in this example, which was 15. So we got to do a little graphing here, just kind of a rough sketch. It says at 0, we have 15,000. Notice on my y-axis, it says the value of the truck in thousands. So I just have to go to 15, which would be right here. Next one, at 5 years, I have $8,857.35. So I'm going to go up here just past 8,000. So I get 6,000, 7,000, 8,000. It's closer to 9, so I'm going to put it probably right in there. At 10, I got 5,230. So I'm just going to go just past 5 here, right in here, perhaps. 15, 3,088. So 1, 2, 3,088, somewhere right in there. And the last one is at 20, got close to 2,000. So 1,000 close to 2. So here is what my nice graph is going to look like. Hopefully you should be thinking, that does look like decay. So that means we did it right, because the car is depreciating in value, it's losing value. Alright, at this point, this video, I'm almost out of time here, so what I'm going to do is I'm going to switch over to the second video. But what I would maybe do before you play the second video, maybe try the next couple by yourself, and then you can just check your answers by looking at the video.